Could anyone on the Zoom just tell me that the screen is sharing, please? Can we just get a confirmation on that? Please. Yes. Okay. Thank you. Thank you. Okay. What's that? Oh, I think it's for the. Interesting. You didn't even have it. I think it's just press go. Okay. Okay. I think that should. All right. Yeah, we can start now. All right. So, hi guys. Thank you for coming. It's a very late on a Monday evening, back right after break. So I appreciate for you guys coming. So yeah. So this is a 61A fall 25 review session. This will be on the post midterm 2 content. So if we look over the topics covered, we have scheme macros, SQL, efficiency plus concurrency, which is a new thing that just got added this semester. So I rearranged some problems that we can do for concurrency just to make sure you guys have that down for the final. So yeah, you can go over scheme and scheme lists. There it is.
So,
If you ever,
okay, yeah. So to start off with Scheme, Scheme is a functional programming language that's going to consist mostly of two different expression types. So the first one of those is going to be our primitive expressions. With our primitive expressions, some examples are going to be like integers and truthy and falsy values. And the way you can think about that is that you can't really break them down into anything simpler. So if you were to evaluate like 3, for example, it would just return itself, which is 3. The other type of scheme expression forms is either a call expression or a special form. So with a call expression, you're going to have something kind of like this. We're going to have some sort of operator that's going to be acting on operands. And for special forms, it's going to look very similar to a call expression, except that it's going to have its own logic and rules when you apply it. So for example, for call expression, we have this plus 1, 3. And all this is going to do, it's going to apply this plus operator onto 1 and 3. And same thing with quotient with 10 and 2. With the special forms, you wouldn't be applying, like, for example, if you're to think about it as a call expression, it wouldn't be applying like if to 1, 3, 5. It would be following the special rules for if using the arguments 1, 3, 5, and same thing with defining an expression. Is there any questions on this part? Okay. So if not, we can look at the process that you take to evaluate an expression. So whenever you're evaluating an expression, you're going to want to start off by evaluating the operator. So if this is like a simple primitive, it would just return itself. But in the case where you have a call expression, you would evaluate first the operator, and then you'd move on to the operands. And after that, you'd apply the operator to the operands. If it's a special form, then you want to follow, like I said, certain rules based off of what the special form is. And important thing to know about Scheme is that it's a recursive language. So any code that you could write in Python using iteration, you'd want to write it recursively in Scheme. So any questions on this? Okay. If not, then we can take a look at some special forms. So one of the special forms in Scheme is if, which kind of functions very similarly to if in Python. So you're going to have if, you're going to have your predicate, which is what you're going to be evaluating based off. Yeah, which is what you're going to be evaluating and what you're going to see, what you're going to do based on the return of that predicate. So if the predicate is true, you're going to do whatever expression is in the next line. And if the predicate is false, you'd want to do whatever is in that expression. For a cond, it works similarly to if in this case, but in this case, you're going to be kind of going through every single you're going to be going through every single different predicate until one of those is true, and you're going to run that one. So you can kind of think about this one as a Python if elif else statement. So you start off with your if that's false, you move on to your elif, keep on doing that until you hit else. Okay. And then for define, if you're just defining a name to an expression, it's kind of like you think about it as binding a symbol to something in Python. So if you have something like define x as like plus 1, 2, you'd be defining x to whatever the result is of evaluating that expression. So, and a similar thing happens with define if you're thinking about it as defining a Python function. So you can have something like the name of whatever your function is going to be, whatever parameters are going to be taken in by your function, and the body is whatever is going to be happening, whatever you call that function with given parameters. And something to note is that define is going to return the name of the function, kind of like as a string, not the function itself. Is there any questions up to this point? Would like me to go over anything again? Okay. If not, look at some more special forms. So we have and or, which again function very similarly to the way they function in Python. And it's going to look at all the arguments within the expression, these expression arguments, and it's going to short circuit whenever it finds the first falsy value or the last truthy. So if you had something like, and if this was like true and this was false, it would keep on going until it either found the falsy value at the end. And if it was like true, true, it would keep on going and return the final truthy value. Or is very similar, but in this case, you would short circuit either at the first truthy value or you go all the way down to the last falsy. So the same examples, we had like true, false, you're running or with them, you would break once you find the true in the beginning. If you had something like false, false, you return the last falsy value. And then something with let, in that case, is there any questions? Okay, sorry about that. So with let, you're going to be, in this case, binding whatever's happening in the current frame, and you're going to be extending the current frame, and oh, sorry, I'm blanking. You're binding each name to the valuation of its expression, and then evaluate the expressions in the binding and return the last one. Okay, sorry. Is there any questions so far? Okay. Moving on. So then another like common form is begin, which in this case you're going to be taking in an expression and you're just going to be evaluating it. And you're going to be returning whatever was the last evaluated value. And then append, you're going to be taking in multiple scheme lists, and you're going to be returning the results of adding all the lists into a single list. And if no lists are passed in, it would just return them. And that's about it. I'm going to be handing it over for scheme lists.
Good, perfect. So, I feel like when introducing scheme lists, it's very easy to just think of previous things that you have already learned in like concepts in 61A. For example, when we look at a scheme list, we can break it down in two parts. The car being like the first input on the list, and the coder, CDR, is gonna be like a reference to the rest of the list. And if we think about like what this, or right now I can put it in your mind, think about what this can remind you of. Thinking of the first of a list and then whatever the rest is. Okay, so there's three ways that you can make a list in Scheme using cons, like construct. It's gonna be, you just cons the first and the rest. Those are the arguments that you have, so those two of them. Another way that you could do it is using the list operator. So list, and then as many elements as you have or as you want. Okay, and then also it's really important to know that when you are using list, all the elements, which could be like other, I don't know, other lists with operations inside, right? These elements are going to be evaluated when they're being put in this list, which is that there's a reason why there is like another third option of making this, which is using the quote. So you put a quote before the elements in the list, and you put element 1, element 2, element 3, whatever elements you have. And the interesting thing is that when you do so, there's not going to be any evaluation on those. So they're just going to be passed in just as you input them. Any questions on that before showing like a little example on the next? Yeah.
So you said like, you put something in the list, like you will evaluate them first, then do it, or
Like I believe, I mean, if you look at the order, I would just focus on like the outcome of it, right? Like you're creating a list, and let's say you have 1 + 2, right?
Yeah.
You're thinking, okay, you use the list operator, is going to evaluate it to a 3, and then like put in the list, right? Like the outcome is gonna have a 3 inside. If you were to use the quote instead, and then you have a parenthesis that goes 1 plus 2, then that expression itself is gonna still be passed on to the list, like 1 plus 2 is not gonna be getting evaluated to 3. And I believe we might have an example in the next one. Or like just a way of like looking at how the structure would work, right? So you already know, like if we define A, we're assigning A to a list. In this case, we're using const to construct, right? Construct 1, construct 2, construct 3, and then nil. At the end of the day, you can think of any scheme list the same way that you think of as a linked list in Python. A linked list in Python is going to have a first and then a reference to a next list. It's going to have a first and then a reference to a next list all the way until it gets to the end where it holds like a null value. In this case, in scheme, we know it as nil. And that's why there's like a little drawing of what a scheme list looks at the bottom, right? If you look at the car of A, is going to be the first value. Same as if you were to do A dot first, right? Or you can think of it as A dot first. And in this case, since we have 1, 2, 3, and the empty at the end, the A dot first is just going to be 1. So car of A is going to be 1. Here, the Kadir or CDR of A is basically the same as thinking of this linked list as A dot rest. And then you get the 2 and the 3 in list format. So that reference to it. And then if you do Katie, I don't know how people will pronounce it, but CADR, Kadir of A, or car of Kadir of A, or CDR of A, then it's the same as doing like A dot rest dot first. So you first access the reference of the rest. So the second part of the list, the second list, the 2 and 3, and then from then you get the first of it using car, right? So you evaluate from inside to outside, and it's like A dot rest dot first, and you're gonna get that 2 value, right? And it's gonna be same for the opposite. A dot rest dot rest, you access the reference, so the second value here. From the 1, 2, 3 list, you access the 2 and 3, and then you get the rest of that as well. So you just get the list with the 3, right? And if you want to get the 3 just by itself, you would just do adding the car of that. So just to access that 3, right now it's a reference to the 3. Do you have any questions about that? I know it's kind of like not work that example, but for that reason, we're gonna have some problems to work on after this. But if you have any questions, I can just throw answers. Yeah.
Do we need to mention nil or link.empty as the last element as always, or is it like a
Yeah.
optional argument?
So in terms of scheme, it is not like the class implementation in Python that the default is gonna be link.empty, right? In scheme, you have to explicitly say nil at the end of the list.
But for linked list in Python, we don't need to mention
Yeah.
link.empty.
And the reason for that is when we have like the linked list implementation in 61A, it's like, you know, the class objects, they have attributes like first and rest, and the attribute for rest, if you don't put any input, is gonna be defaulted to link.empty. There's no way that we have that in the scheme implementation of it. So that way you also have to always be explicit. So always at the end of the list, you want to make sure that you're putting nil, just to make sure you declare that that is the end of the list. And that's gonna come in key for some of the questions that we're gonna do right now. And if we just, yeah. Okay. I think it's best to read this out loud together, and afterwards, maybe you guys can have some time to just work on this problem. So first, the first thing, and I think the biggest advice that you can have in 61A is take your time to really understand the problem, because so many times you go into that question, you're working through it, and then you look back at the question and you miss something, and then you suddenly waste a lot of time. So you want to make sure that from the beginning you have a good understanding. So this question is called Bedazzle, the scheme, well, doesn't really matter. Okay, so we implement make necklace, a scheme procedure that creates a scheme list where each value comes from a given scheme list of beads. And the beads are repeated in order to make a necklace of a given length. For example, if we make a necklace out with, and then you have 2 symbols and a length of 3, the linked list will contain will alternate between those two that we inputted, and they create this diagram. So in short, these are the two values that we want to be repeating to until it has length 3. So we'll first have a swirly line, then a star, then a swirly line again. So that's how you can think of it. It will just repeat and alternate with each other. Any questions on understanding the problem? All right, if nothing, right now, just try and work on the problem a little bit yourself, and if anything comes up, just raise your hand. So sorry, I forgot to go to the next. There's a skeleton kill, by the way. Okay. So I hope that was at least enough time to start working on it, or like thinking about this problem. So let's kind of work on it together. So first, we know that when we work on scheme problems, we're gonna be doing recursion instead of iteration, right? Like we cannot just go like a for loop or things like that, right? So first thing that we want to do is establish a base case, right? We have the problem here. We have a second input, right? A second value that is gonna tell us how many times we want to, repeat this pattern and take this length, how long we want to make this necklace, right? So that value, every single time we can think of it as, okay, we do 1, and then we have 2 left instead of 3, right? The next one, we're gonna put another one, then we're gonna have 1 left. Then we're gonna have another one, and then 0 left, right? So in this case, when we reach the end of the list, and this is gonna be like a really common one, it's good to practice so you see like different iterations, but like common one is usually when you reach like a 0 of a value, the length is going to be, does anybody know what we can be returning here? when we reach 0. So remember, we're making a list. What happens when we reach the end of the list? Yeah.
Just like no.
No. See. Yeah. So that is the use case. It's pretty similar how in Python we have like a linked list problem, and at the end, you return like if something is 0, you put link.empty, right? So in this case, it's like that. So when we know that we have reached the end of the list, we just want to be returning the no list. Okay, perfect. Oh. Okay, so now if that is not true, we still have work to do left, right? So the else statement, which is like on the cons, right? There's gonna be some statements over here. We're constructing the list using cons, right? According to the structure that they gave us. And what is the value that we want to put? As we look back here, we're given a list. We're giving a list of the symbols that we want to repeat, right? And this list is also like a scheme list. So what value, we're at the beginning of the list right now, what value do we want to return, the squiggly line or the asterisk? Squiggly line, right, the first one. And that is why we access this list and we get the car. In this case, it will be like the squiggly line, and we put it at the first of the list that we're creating. That's good. We have the first value. Now we want to make sure that we have the second argument, like the rest of the list, the second part of it, or like the reference. And in this case, we can see from the structure is going to be a recursive call. And the recursive call will have 2 arguments. Does anybody want to kind of give it a shot on what they think? Yeah, so hand over there first.
You say curve beats.
Curve beats.
In car. Minus
That's the one. Yeah, you want to say something?
For D, I think we should type in curve beats and the list containing the first and beats, so just like list of car beats.
Yep. Yeah, I believe that's same. So we can just see. Okay. So how we can think of it is, first we're appending. We do the recursive call, right? And we passing on the list that it says of the rest of the beats, right? And then we're bringing the first of the beats. So we're basically, if we had squiggly line asterisk, now on the next recursive call, we're gonna have asterisk squiggly line. So you put the first one at the end of the list. This is gonna be iterating. So if you want to, for example, repeat 1, 2, 3, the next one's gonna be 2, 3, 1. Next one's gonna be 3, 1, 2. So it's going to be just putting the first one at the end of the list because we're always grabbing from the front. Yep.
Is it also the same if you do like list car beats or quote car beats or like quasi quote car beats instead of the last?
So if you do quote Kirby, I believe it wouldn't be the same thing because you're not evaluating what's inside. Like when you're doing car like beats, you're evaluating like the first value, right? So that one wouldn't be it. But you said the other option was what? Like this.
List car beats.
I believe that could still work.
That could
Yeah. There's like multiple different approaches, but it's because there's so many multiple ways of making this. So yeah, it would evaluate the things inside. Yeah. You can go first.
For the base case, if we do length as 1, can we return a list of car beats? Because in the question it says length has to be greater than but a 1 value.
So your question is like
Instead of length being 0 as a base case, can we have a base case where length is 1 and we would just return the first element of the beats?
oh, okay. Yeah, I believe that would just move the base case like one less recursive call. Yeah. So it would still work. Yes.
Right. For the cons, like at the end of the cons and no, like you just do a list of like card beats instead of just cons and go.
Yeah, I believe that's the same thing. Like you're getting like a second list, you're appending it to it. So you would, I believe it would still work.
Oh,
As long as you make sure you have the like the nil at the end.
but you can't use quote, right? Just quote.
Quote, you wouldn't be evaluating the thing inside. Then you would get the expression back. You wouldn't be evaluating to get like the car or the Kadur. You would just have like car A.
Yeah.
Into the list, into the risk.
Quasi. It's like if we quasi could be entire list, but unquote the card reads.
Think about that. I'll still,
Like quasi pull parentheses and then
Unquote the
comma
card.
car beats inside that.
Yeah,
And
because we ultimately want to.
you're seeing this is one home.
yeah, and another thing is like, I believe we're gonna send this last up too, right? A good thing is to go on like the 61A. There's like the Python one and the scheme one, and just like you can go in and like also test yourself and you can visualize like what the list look like. That is a really good tool that you can use. And was there another question? Oh, it's nice.
No, I was just wondering, like, when do you suggest we use like append versus list versus columns?
I mean, like the simplest use is you append when you already have like you use a pen, you already have a list, right? You don't want to be having like a list within a list in this case, right? Because we just want the list of the values, right? So we append like the CDR here is an already existing list, right? So we're just adding something else to the list. In terms of list, like if we were to do list here. Oh, I see what people meant earlier when it was like using list to construct it instead of a pen, right? The problem there would be that you're making a list with two input values inside two arguments, and the arguments inside would be lists themselves. So it would be a list containing lists. So it would be like nested lists. So you can think of when you want to have a list inside as an argument, or when you want to have like the value from that list as an argument. Okay. Is there any more questions on this problem? Okay, we also have another problem to go through. Oh. Like, okay.
There's a little bit of a spoiler for this one, but that's okay. So for this question, it's called a parentheses scheme, and for this one, the background for this one, in a fit of scheme-induced rage, he decided that all internal parentheses must be eliminated, implement the procedure remove parents that takes as input a scheme list and returns that list with all internal parentheses removed. So I think just a good rule of thumb for honestly, any exam you take in CS, like going forward, is if they give you a doc test, you really want to stare at this and make sure you understand what's going on. So in this first one, we're using remove parents and we're taking in this list right here. And as you can see, we have this first like list here, like nested within this list. And then once we look at this list, we again have another nested list in here. Similar thing over here. Again, it's still another nested list as this element. And within this list, we have another nested list. And again, another list. And if we're looking at what remove parents does, it takes like this nested list and calls remove parents on that kind of again, because you want to think about it as kind of flattening the list within this first element. So what ends up happening is that any nested list all get flattened into this like 1, 2, 3, 4, 5, 6, 7, 8, instead of being like list 1, then 2, 3, like 4, 5, list 6, list 7, list 8, 9. 8, 10, sorry. Does that kind of make sense, like what the function is doing? So, and then again, if you guys kind of like need some more time to kind of understand what it's doing, I definitely recommend taking a look at this other doc test and kind of trying to like argue with yourself like what happened when with remove parents and how it gets to here. But if not, I'll give you guys some time to look over this question and we can look over it all together. We can go ahead and start looking at this. So I know this is kind of giving away what's going to happen for blank A over here. But another good thing you should do whenever you have one of these code writing like questions that gives you skeleton code is kind of understand what the skeleton code is setting you up to do. So we know this scheme, we know this is list, so we know we're going to be doing recursion on to like achieve whatever the process is for remove parents. And the skeleton code here is giving us this kind of like this const statement. And the first line of this is null. If S is null, then you want to return nil. Again, since we're working with recursion, we can know this as the base case. So what this is saying is once we reach the end of S, we want to return nil because we know that we've looked through the entirety of S, and we know that it's meeting the conditions for remove parents. So in this case, we know that there's no more nested lists. So with that being said, what's one of the things you'd want to like check if you're going down the list and you want to make sure you can get rid of all of the parentheses in there? Again, it's kind of given away.
Each element is a list.
Yeah, you want to see if the first element of the list, so car S, is a list. And if that element is a list, what would we want to be doing there? So you can think about it as like kind of this situation where this element is a list.
Probably want to be using recursion where we use remove parentheses parents, and then we have like some sort of like maybe append and so on.
Yeah, pretty much.
Yeah.
So what we're going to want to do is that we're going to want to join the result of calling remove parents on the car. So in this case, we'd be looking at like this guy right here. Then we want to join that with the result of calling remove parents on the footer of S. So that would be kind of saying like, once we remove all the parentheses from this guy and all the parentheses from the rest, that's what we're going to be wanting to return all joined all together. Is there any questions on that? Yeah.
Why is it necessary to do remove parents on cars?
Yeah. So again, kind of like if we're looking at this first case, this is like a really good one to understand. Is if you have car S here, we still don't know if the inside of like car S is a valid, like non-nested list. So in this case, since this is nested, we still want to look at car S and see if there's any more like nested items to get rid of. Does that make sense?
Yeah.
Okay, perfect. Anything else? Okay, so now we know what we're going to be doing whenever there is a nested list. So now we want to think about what we want to do if the if the element at that moment isn't a nested list. So in that case, what will we be doing? Guesses?
For else?
Yeah.
Just doing remove parents on the trigger weapons.
Yeah, since at that moment, since we know that the car is all good, we know that that's not a nested list. All we really need to check at that moment is just the rest of that list. So it's going to be cooter S. And we want to join that with the first element since we know that one's valid. Is there any questions overall for this part? Yes.
What would happen if we use list and the CO? So forms.
Here?
Yeah.
Yeah, it would cause a nested list. So this entire thing would be nested in there. Instead of having it all as like one list altogether. Does that kind of make sense? So it would kind of end up as like a list. Oh, it'd be, oh, I see. Hmm.
They're creating a list with like two elements though.
Append
They're
remove.
creating a list with two elements, where the first one is car S, the second one is just another list, which is remove parents footer S.
Right.
So when you want to combine them instead. So columns will combine them effectively, but list will just create like successive nested lists.
Mm.
Okay.
Oh,
So other questions?
What if we did list in second blank, right, instead of append?
This year? I think it would still go into that same issue because remove parents is going to return like a flattened list, like ideally. So we have like a flattened list here, and then we have another flattened list over here. It wouldn't be like all joined together. So it'd be two nested lists. Any other questions? Okay, if not, I can hand it off to the next topic.
Yeah, so I'm gonna be presenting this stuff on macros. Are there like, okay, here we go. Okay, so before we understand macros, I guess it's necessary to understand the difference between quoting and quasi-quoting, which did come up earlier, but essentially, just to reiterate, quoting will return like the entire expression without evaluating it, but with quasi-quoting, you can evaluate certain sections of the quote expression with a comma. So like if this was just a regular quote, like this quasi-quote expression, if it was just a regular quote without the comma, you would literally just get like parentheses plus one, one. But with this quasi-quote thing, you can take this comma and evaluate this to 2, and then just return plus 1, 2. Right. Now that we know quasi-quoting and quoting, I can tell you the difference between defining and define macro. So define macro, unlike the define method, the define macro like returns a list. Well, it returns an expression that is also a list, because in scheme, expressions are also lists. But what you want to return from a macro is a list. Whereas here in this define method, like if we do this define twice expression, what happens here when twice is evaluated on print2 is print2 itself is evaluated first. Like you remember from Python, the stuff inside the method gets evaluated, and then successively the outer stuff gets evaluated. So print2 gets evaluated, which gives you 2. It prints 2 to like the standard output, and print2 itself returns nil. So then it will return this begin nil nil, which like twice itself returns a list with begin nil nil. Whereas here's what happens with a macro. What was it go? Okay. Yeah. Here's what happens with a macro. First, this print2, the list, is bound to the variable expression, and then the body of the macro is evaluated. So print2 is inserted where expression is in this list definition in the body of the macro, and the macro will return this particular expression, which will evaluate literally to begin print2, print2. This is then evaluated outside the macro. So then this print2 is evaluated, which prints 2. And then this print2 is also evaluated, which then also prints 2. So this is why you get 2, 2 printed right here. All right. Here is the first question related to macros. Okay, so we are trying to create a macro that outputs this lambda expression right here. Let's see. I think maybe we'll just do like 2 minutes. I'll give you 2 minutes to work on it, and we'll get to it. Okay. I guess you can start going over it. Yeah, so fundamentally, yeah, so as with all macros, we are trying to return a list essentially. So, like for example, for this first doc test, we're trying to return that lambda. So thankfully, they've already given us this lambda y part. So all we're really doing is trying to find this body expression, which is a list, right? Um, and we can see that they give us the first part of the list, which is like the parameter uh we're passing through to the macro. They give us the first part of the list, and we also have to tack a y onto the end. So, like, what is the thing that we can use to, I guess, combine what they give us and the y?
Okay.
Yeah, you can use a pen, absolutely. Um, let's see. Yes, we can append what's given to us call, and then but remember, append takes two lists, right? So what do you have to do to y?
List one.
Yeah, exactly. We do instead of just doing y, we do parentheses list y. However, uh, wait, okay. Oh, they give parts in. Okay, yeah. So we are combining call and list y, but remember we've quasi-quoted the whole thing. So not only do we want to we've quasi-quoted the whole thing. So not only do you want to like figure out what this list is, because you don't want to literally have append call and list y outputted. You want to figure out what this expression means, but you also want to keep y. So in this circumstance, what should we do? Sorry?
Unquote.
Yes. Yeah. So what we do here is that we unquote append call list y. So now we know what this thing evaluates to. But then we also quote y because we want the literal y variable because our lambda takes y as a parameter. Any questions on the question? Great. All right. We got a second one that's a little harder. They've robbed us. They've taken if from us. So we got to recreate it with or and. Like 4 minutes, maybe 4 minutes will do. All right. Yeah. I think if you're a little lost, it's going to help if you remember short circuiting with regards to and or, which it's I think it's going to help here.
Previous question, but
Yeah.
like quoting list, like uncoding, quoting y within, like quoting already gives a list. So do you need like list and then quote y? Like can you just
Would you
quote
need
y?
the variable?
Like can you just quote parentheses y?
Um,
Oh, sure.
Yeah, you can also do that.
Okay.
That'll work. It's also shorter. I think on exam, just do whatever is most intuitive to you.
Wait, what are we putting in? Like, what do we put in the end?
Just self.
This is also good. This, they will be which is one predicate history. So we knowledge predicate expression 100.
So this make up.
Then we.
Okay, I think we'll start going over this one, which is kind of difficult. For this question, we're just gonna define oh yeah, well, we know what the if statement and scheme, like the format of it's supposed to be, right? We get a condition, then we get something to return if the condition is true, then we get something to return if the condition is false, right? I guess, yeah. So we're just gonna define like condition to be your Boolean variable, then will be the thing we return if condition is true, and then else be the thing we return if condition is false. So since they've taken if from us very unjustly, we are left with only or and to use. So in this circumstance, how can we I guess what expression can we construct using the stuff we've been given to return the condition, sorry, returning then if the condition is true? Wait, let me just see. Yeah. And in case you just need to jog your memory, for the short circuiting stuff for and or, and will return the first falsy value or the last value in the set of parameters passed to it, or returns the first truthy value or the last value. And in scheme, the only falsy value is like #f. Everything else is just truthy. Yeah, so if our condition is true, can we create like a statement which is like and to return the then value using the short circuiting principle? Yeah.
And condition then.
Yeah, exactly. So in order to so we can do and condition then. If a condition is true, then it will return the then value, because it will return the last value in the set of parameters passed to it. But let's see. Oh. Yeah, in a certain let's see. But yeah, what if our condition is false? Right? We gotta deal with if a condition is false, what do we return?
Else.
Yeah. We will just return else. And you can choose between the two with this or statement. Right? But depending on which value is true. How do we format that given this special case? How do we format the stuff that goes in this blank? This with the question mark. Well, essentially we can just do yeah, and not condition else. So if condition is false, it will just return the else statement. But we also have to remember, we've been dealing with all this, but we're also doing a defined macro. So we have to return like this whole expression as a list. So what symbols can we put here, or where can we put the symbols so that you can return a list, which can then evaluate to the appropriate expression you want to return from the if statement? Yes, you can quasi-quote. If you can put a quasi-quote in the front here, what do we unquote? Exactly. So we put a quasi-quote in front here, and then put unquotes in front of everything we want to evaluate. Because like if you look at the doc test, I guess the doc test, this gets evaluated like everything here gets evaluated. So you want to unquote this condition, then and else, so we know exactly what to return from the if statement.
But, for the second form, do we need the and not condition part? I'm just use else. That's it, stop being the and. But I feel like if the condition's false, we don't need the second part.
You're saying instead like or and condition then and then else?
Yeah.
Yeah, because like if the first one is false, then you could just short circuit it like else, like you just output else. Yeah,
I see. Actually not sure. Do you think? Well, instead of and not condition else, you just do else. Because they're saying take advantage of the shortcut, short circuit. So. I think potentially can work.
Yeah.
Yeah, I think potentially can work, but I would advise you to try it out on the scheme simulator online, just to make sure that it works. Any other questions? None? All right. I guess then we're moving on to the next topic, which is SQL.
Okay, moving on to SQL. The SQL portion on the test is like usually the most like scoring one because there's looking not a lot of like variations they could ask of like the same problem. So yeah, small little heads up. Yeah, so like what is SQL, right? SQL is just like a declarative programming language. Is different than like our like the programming using Python, for example. Like you just like describe how you want your output, and the interpreter or the engines figures out how to get it. So it's really simple. It's like you don't describe any algorithm, if that makes sense. You just describe like what your output, what you want your output to be. That's all it's saying. Yeah, small things about SQL. The basic syntax, use a semicolon after every like line or query instead of Python where you just like leave it. Also capitalize keywords, which we'll go into like I think select and like tons of other like commands, I guess. And then yeah, so let's get into it. So the first one we'll go into is like select and from, which is like a common pattern. So for any given table, we can the way I think about it is like from what table or tables we're picking from and what columns we're picking from these tables. So it's pretty simple. It's sort of like English, so you can remember. Yeah, it's also case insensitive for naming. So let's say the original table had like price with like a capital P, like a lowercase price and a capital P price will also work. So that's like a small edge case you can think about. You can also do like arithmetic, which is like kind of fancy, but I could say I could put a comma over here and say weight times price as well. So like you can combine columns, you can add columns, you can do all sorts of stuff like that. Yeah, that's about it. Any questions or just looking for
So how do you combine columns again?
you just use like an operator. So if I want to weight times price, I just do I have an extra comma over here at the column name weight, and I put like an asterisk times price. So it's like a simple and then I add obviously a semicolon. Okay. Yeah, okay. The next command we're looking at is where. So where is like given all the columns you have, what's the condition I want to check on? You good, bro? Yeah. All right. Yeah. So like here for the where, like the condition is mainly the focus. Also notice the case sensitivity, like though price is like with a smaller p, you can also have like a capital. That's also fine. Yeah, so we usually have where and a condition with the column saying you want price to be less greater than 10 or less than equal to whatever. You have like comparative operators and tons of stuff like that. Sure. Also, the slides will be posted after. So Yeah, so this one thing I do want to note though, it's like though the column like comparison is case insensitive, the actual text, if you use a string, is like sensitive though. So let's say like I want like all the rows where where the name is Apple, right? Then when I do like where the column name is equal to Apple, I have to mention like A with the capital because that's what is actually in the data. Does that make sense? So you can't really like mess around with that. Yeah, so I just mentioned it over here, and a really small thing, but if you want to find out, let's say like all the rows where a value is null, like let's say sometimes it's like no data values. I don't think it's ever gonna come in 61A problems, but it might. When you do that, then you can say, oh, name is instead of saying name is equal to null, you say where name is null. So it's like a special like SQL condition. Does that make sense? So like when I'm searching for like values that just don't exist, like let's like one example row like nothing and like 1,000 and like 50, right? There's nothing over here, and I want to select every row where I want that has like no value for a name. Then I say name is null, where name is null. So like a small condition. Yeah. So the next is order by. Order by is like pretty intuitive. It's just I guess orders like your row tables by whatever condition I wrote here. It's by default it's just ascending. So if you want descending, you just say order by the column name and then DSC. I think it's ascending. Yeah, this is pretty simple, but I do have like a question for you guys. But imagine like I think there's an example over here. Yeah, I wanna order by let's say I want to order by weight, right? Or descending by weight, just like exactly what is over here. But you notice there's a tiebreaker over here. So for orange and apple, they have the same weight. But so okay, what would you think would come first if I just like ran this like verbatim? Like would orange come first or apple come first?
Orange.
Apple.
Well,
Orange.
okay, the real answer is like it's really random. Like unless you specify, like you'd never know. Okay, so you guys, when you say order by, right? Let's say you want to order by price next. You gotta add a comma over here and write price if you want to make sure that you want like that specific order. Does that make sense? So like in reality, it's like completely random. You can get like orange ones or apple ones. So yeah. Spotted. Yeah, this is just the question. So if you want to order by price, you just mention sorry. Yeah. So,
I was wondering, like, how do you order by like alphabetical order?
I think you just put in like name. Like I think it's automatically like, right? Looking for that. Like if I wanted like ascending or descending order, I think you just like write name. That should work.
Wait, so the bottom one just means like order by weight. If there's a tie, then order by price.
Exactly, yeah. Any more questions? Yeah, and then last one's like limit. The idea is like, oh, sorry. Over here. Yes, yeah, so limit is just like you want like a top and like when the question is like top, I want like a top 5 or whatever condition, usually use like a limit. Yeah, limit usually comes like after. Notice like after like from where and order by, you have a limit like at the end, and that's usually the format. And I think there's a slide that goes to like common formats, so you don't have to remember that for now. But yeah, and a limit usually like follows. Okay, I guess I have a question for you. Like, if I have a limit without an order by, would that ever like make sense? Like, if I have like assume the same problem, but there's no like order by line, and there's just a limit. Like, okay, why would that ever make sense? Like, no, okay, I'm just like, I guess the idea I was trying to get is like,
You just take the original order.
yeah, it just gives you like a really arbitrary order, right? If it's like limit like 20 with just like a random table, like you just get any random like 20 like things. Like there's no like order in any sort. So like limits usually used by with an order by. So you order by something and then you like I limit the top 5 or like the bottom 5 or the lowest 5. So
Wouldn't it give like the first row or like first 20 rows or
Yeah.
something like
yeah,
that?
first 20 rows, but like usually, but in like a data table, like it's more meaningful to get like the first, like the highest 20, like I don't know, like highest 20 prices or like highest 20 weights. Like you could do a limit, like the regular table, but like you just get random rows. Like you just get the first like.
Is it going to be then? Or is it?
I mean, like in the actual data table, like when you actually want like query and stuff, like you much rather. I mean, like what would you like the top like 15 like things? You know what I mean? Like you much rather have like a condition and then get the limit of it. It's a really complicated way to say it, but my point was like usually limit is usually followed by an order bracket. Yeah, that's the question. And then yeah, another actually this is like second part of SQL was like kind of confusing, but yeah. So if you have something called a join, and the join, the whole idea of a join is just lets you combine rows from two tables whenever they match on a column. So that's like the TLDR of a join. So yeah, so we have like two tables like orders and foods over there. And oh, hold up. Yeah, if you notice, in the orders table, we have a name and we have an ID. So like this person bought this item with this ID, and that's like the actual like what the ID is. Like its ID, its name, its weight, its price, or whatever. Got it? Can we move on? Or alright. So yeah, this slide is a little complicated, but let's break it down. So whenever you join a table, I want to look at this first, right? So I'm gonna start from the from statement. So from foods as F and orders as O, and this as statement is like an alias. We just use it for like naming convention purposes. So like if you have foods as F and orders as O, you can mention like from what column, like which table you're talking about. So this as is like a pretty common thing. And the big picture intuition is that once you do joins, what actually happens is like I'm going back. So for every row in like the orders column, every single where it is on the first step is like it copies every single column in foods column and attaches it to this. So you can think of like if it's 1, 2, 3, 4, 5, 6, and then so that's like 1, 2, 3, 4, 5, and then 1, 2, 3, 4. So 5 times 4 is 20, like a 20 row like table. Because for each of these order like rows, you have a appended row right here, and all of them we appended. Okay, it's like step one. So that's what this is doing pretty much. So the from statement's doing, and then the where statement is like the important part. So where FID is equal to OID. So this goes through its columns, and if you notice, like it only select the columns where the ID matches. So if I have Kevin Moy 1, and then in the other column the other like appended row, I have 1 orange 140. It only like if the ID matches, so 1 and 1, it'll consider it as a row. If it's like 1 and 2 over there, it wouldn't consider that because the where condition would like ignore that. That makes sense. Does that make sense? So like the idea is like it just takes every single possible like iteration. It just picks the one where the ID matches. And then we select our column names. O dot name. So we select O dot the name from the orders table, and then F dot name. So the actual food over here. So this is what you end up with. Right? Does that make sense? Yes.
If we use join instead of commas, or to join the
This one?
Yeah.
Yeah. It's an equivalent syntax.
So can I interchange where and on, or should I use on specifically if I use join?
Yeah, you have to. Yeah, it's fine. I'm pretty sure, but yeah, it's like you can use either the syntax or it can't. I don't think it mix.
I cannot use
Yeah.
where, here, and on.
No, I don't think so. But I'll get back to you on that. I'm pretty sure you can't. You can use inner join or join, same like similar thing. Yeah. So like the process what I just described of like every single row having like being attached to like one row and like picking like the ones you want is called an inner join. Yeah. That's about it. For join tables. Any more closer?
I noticed that you don't have to. You know, you didn't put
As
and-
for here.
yeah.
I mean we did, right? I mean it's just implicit as. It was like
Oh, really?
yeah, I mean you can use as over here. I think yeah, I should have added in the slide, my bad, but it's considered from orders as O and then for roots as F. Yeah, any more questions? On. Yeah, and this is like the last portion. But aggregation is like the idea of aggregation is like you want to compress many rows into like a single row by applying a function. And the functions can be like called the array functions, like sum, average, count, min, or max. And this is where I think grouping also comes in. So we can talk about that. Yeah, so group by is it takes every like unique element in the name and gives it a separate like group. So what it does is like so we don't have a table for this, but what I like to think it does is that it takes every unique element of name, puts and gives each of the name a separate table. So if I have I'm gonna go back here, right? If I have like this table, the orders table, right? So it goes through every unique possible like value in name. So it's Kevin Moy and there's Jason Chang, right? And it gives each unique element a separate table. So like it separates like the Kevin Moy into one group and the Jason Chang into another group. And if you have like any other unique values, it'll separate their own different groups. Okay. And then yeah, sorry. And then this having condition is checking for what in each specific group's own like table, it's checking whether this condition is met or not. Okay. And then so this asterisk just means like all the rows, and then count of all asterisks just means like what's like how many rows does this table have? Because you think about it, like we're splitting this into like its own groups, right? So this count of asterisks is like how many rows does each group have? And then it's only if it only has like greater than or equal to 3 rows, then we'll include it. And it will only display its name. So it makes sense for Kevin Moy to be here because there it's like 3 instances of Kevin Moy. Right? And there's only one of Jason Chang. Yeah, so that's like the idea of group by or having. So you group by any column, and then you just check like something related to that group. So you count is one thing, like how many rows it has, or like the sum of like maybe there are other attributes, like anything. But you use like these are usually the regular functions they use for it.
Yeah, for having, do we always use aggregate functions?
Yeah, you have to, right? Because you're selecting which group to include, right? And you also like the final output is like one row. Like for every like group like table I'm talking about, the final output can only ever be one row. So you need like an aggregate function to like compress all the rows somewhat. So it makes sense to have like sum or like an average or something that takes in a lot of values and splits out one. So yeah, you do need an aggregate function for this. Does that make sense? Any more questions? Any confusions?
If we were grouping, like let's say if we join the table sum of to get the sum of the fruits or something,
Wait, sorry. So you join the table, okay?
like
Join on ID,
join
sure,
group prices.
sure. Yeah. For every if you join it, yeah, you have name ID, and then it's depending on the ID, you have like the orange, weight, price, type. So yes, this would be orange. This would be apple. Yeah.
Yeah, if we join these two tables and sum
And-
the fruits, like the sum of the
Okay.
prices
Some of the price.
of
You're
the
saying
fruits they bought,
okay.
and then trying to group by the name and
Sure.
see
Yeah.
whose sum is greater than like
Yeah.
a certain number.
You can do that.
When we select the columns in the beginning,
Yeah.
how should we visualize the table in the process?
That's a good question. First, I would like I'd think of what like the table, the end table I'm working with. So like for orders and foods, as you said, I'd first like think of like what the entire row looks like. Right? So I would think of like orange. This is really neat. 1, 2, 3, 4. So like you can think of orange and apple and ribeye, and all that row like over here. And next I'll think about like what my group by is. So what column I'm actually grouping by. So what is like, sorry, it's not the, is it? Oh, it is. So group by what specific column? So yeah, go over here. So what specific, like, assuming we're doing my name and like seeing the total number of like prices they bought, right? So I'd be like, okay, so I'm gonna separate these into one like group. This is another group. And then I'm looking at what the function of doing is. So in your case, that would be like sum of price, right? So it'd be sum of price. And I'd be like, okay, for this Kevin Moy group, what's the total price of whatever you got? So maybe 1, 2, 3, right? You can just do like 3, 11, and because it's $100. So like you add all of that up. So you have like what 114 or whatever. And then that would be your final row. So that would be Kevin Moy. I guess I have an ID, but no, you can select. So you select what columns you want to show, right? So I can do select name, comma, sum of price here. So I would have like Kevin Moy and the total like calculated thing. So this is like done for this process is done for every table.
So when we group, we'll have multiple tables with unique values in that group.
The no, one group has one table.
Yeah, and like
Yeah.
one unique group will have one
One's
table.
almost own like
Its
table.
own table.
Yeah. I mean, it's like an intuition. It's not actually a table. It's like a midway through a table. Like so, like in the process, it just groups like that way. So it splits it into like the data we split into that way, and then each of it will be grouped.
So here's a question, what happens if you want, like, do you want to group it by count, or like, at max, for example?
Group by max.
Yeah, like each group's like max, how would you do that?
Oh, yeah, I mean, you can do the same thing, right? You can just group by whatever name, and then you can just say max of whatever value. So max of the price of the item you bought.
Just like name, comma, max of the.
Yeah. I see what your question is. So yeah, over here, you select, right? You just like add a comma and then whatever like header function and then whatever like column you're working on as well.
Okay.
That also works. And this having is just like so great question. Yeah. Having is just like to like eliminate the groups that we don't really care about. Any questions? This is like a neater visualization, I think. So assume like just like unstructured data, and then you're gonna group by the year. So like you see like it's not like a table, but it's like a mini sort of like just group. So yeah. So the 1910s over there, 2005, 2015, and then for each of them, I want to like get their sum. So sum of whatever this table represents. So they sum that, they sum this, and they sum this, and this is like the final. It would you get out. So
When we group the tables by year,
yeah.
how are the rows ordered? Are they just random?
You mean like these?
Yeah.
Yeah, I think that's right. Any more questions? Yes, I would write this down because this is like a common pattern you see on like in tests. So the first one is like it's usually like top N type questions. So you can get like the what are the top 5 I don't know players or like number of points or whatever. So when you say like a top question, this is usually like the format it follows. Like you get a table, you filter by conditions, you order it, then you limit it, and you select whatever table columns you want to show. And then 1 second. Yeah. Yeah, and the second is like if you have a table, you want to group by some specific like column. I only want these set of columns, and this is like my rows I want to show. So the aggregate function, so some whatever, and the non-group column. Yeah, and this is a non-group column because you can't really like group. You can't really like sum on. But you can't really do any functions on the column you group by because all of it's going to be same, right? You know what I mean, so yeah. If I group by like price, like it's all going to be the same price. So like it doesn't really make sense to a function on it. Yeah. If it's all good, I think the next is a question. Yeah. Um, um, sorry. Actually, I think let's do this. I think this is like a way more simpler way. I'll give you like 2 minutes or how much ever you need. Or one, three. Yeah, actually, I forgot about that. My bad. So the idea is like you want to find all the quarters in which more than 10 points were scored. So this represents like an ID for a quarter, I think. So like it's like quarter 1, quarter 2, quarter 3, quarter 4. And then yeah, these are the points that were scored. So at quarter 4, they're like a combined total of 1, 2, 3. So this plus this plus this. Quarter 2 was this plus that. Like, yeah.
My question was like, what are the tables names?
Oh, sorry. One more. This is scoring, and oh, I think I should show you this then. What's like scoring? Okay, sorry, my bad. Okay, I think we'll start going to the answer because we don't looking at that much time. But oh shit. But I guess whatever. Yeah, so this is like how you think about it. So from is like all the tables you pick that you need, right? For this problem, if you see, I don't really need what the person's like name or team, like the team they represent, right? So I just need the scoring table. So I just get from scoring, and then I group by each quarter because I want to find out which quarter had like more than 10 points. So I say, so I group by quarter, and then after I do this check, so I sum all of the points per quarter. So if you notice, like all of these get aggregated, like quarter 1 like one group, 2 would be like one group, and then 3 would be one group, and then 4 would be one. And I would sum every single point for each group. So, and then I would only select the ones with greater than 10, because that's what the question asked. And then I just like give the quarter, because that's the only column they actually want. So,
If I join the tables and still this is in order, is it going to be the same one?
I mean, you could join the table. Yeah, that would be the same output, right? But then like you just have this unnecessary information that you ever need. But yes, that would work. Also, usually the test like it's like constrained like this, so I don't think you can have a join in there. But yeah. We can do one more question or if, but yeah. This is the same like same tables, but yeah, like the problem statement is like you just need to join it this time and then figure out like the scores per each team. So you need 2 tables for sure. I'll give you like 3 more minutes for this one. and we can do it together.
Yes. Still, I don't think that. It was. Where? Yes, the. Go to. Yes.
Okay, we'll start slowly building up to the, sorry. Yeah, so the first like step, I guess, like, do we need both tables or are we just fine with one?
Both.
Both, right? Yeah, okay. So from table scoring and table players, right? And what condition do I need to make so that both of them are like aligned? Like in a sense, like when you join the table, like every single like row over here has like a copy of that, right? So what's like the condition I need to make sure that they're like the same?
Player equals name.
Exactly. And then once I do have that, what would I want to group by? Because exactly, group by team. And then what are the two columns I want to return?
Team or sum of bonds.
Exactly. Yeah. Did everyone like understand why that is? All right, cool. Do you want to skip the next problem? Because we're running out of time. Okay, fine. And then you can probably do this homework problem like on your own time, but we'll go on to efficiency.
Rephrase efficiency is like until this point, you've been able to just solve problems. You've noticed that there are so many different ways that you can like answer a question, and sometimes like your code is really small, sometimes it's really big. There's so many different routes you can take, and sometimes you want to just make sure your thinking fits the skeleton, right? But in the real world, the one deciding factor that tells you whether your code is good or bad is how efficient it is. And the reason why is think of it in terms of like what software engineering could be, right? Like not just creating something, but let's say you work at Instagram, right? Like you want to make the app to work really fast for the user to have a good experience. And also you're able to create something that doesn't take that much computation. It's more efficient and you save the company money. Both parties win. And that is kind of like the meaning of why your code should be efficient, right? So that is a good introduction for a topic that you're gonna see later on more in like 61B and other courses, but it's a good thing to start thinking. And in 61A, you can assume that since it's like a really small topic, it'll probably be tested like most likely. And it's very easy to do good, just understanding and spending time to change your way of thinking about coding into thinking of how to make your code efficient. Yeah. So assume that there you have like an input in a function, and we can gonna call that input anything, and it's gonna be, well, we're gonna call this input n. And depending on the size of n, like as it approaches infinity, if it grows, like we're not stopping, like if infinitely like large n, we want to see what the order of growth is, which is like, for example, let's say let's say okay, let's just actually just hop on the next slide. There is multiple kinds of orders of growth, which is why I want to stress on first. There's constant, which is, I can give you an example for constant. Let's say I ask you, say your name. Yeah, Jay, and say your name. And you say your name.
Aaron.
Yeah, like it's just one thing per person. Like if I ask one person their name, it'll be just constant. It's just one thing every single time, right? And if I ask you to name everybody in the room, now it depends on the size of the room. And it will be you naming person by person by person. And that is, for example, linear. And logarithmic is somewhere in between, where each time you reduce or cut in half. So this is just ranking of how efficient things are. Like if quadratic would be every time I tell you to run through the same thing twice, like the same list of people. So it's kind of doesn't mean a lot. Like when you're not actually seeing like the math proof, but the important thing is to remember this order of growth, and we're gonna see how we can recognize it in some of the questions. And also there's like a good chart of seeing, like at the start, they're gonna be all over the place, right? But where we care about efficiency is later on, where it reaches like a really large like value, like infinitely large. Then you can see like the difference between like a logarithmic in terms of like runtime that it takes you is so different from a one that's exponential or quadratic, right? In small numbers, it will make a difference. But if it's like a huge number, then the difference, the gap between those runtimes is gonna be massive. So that's why we care so much. Okay. In 61A, some of the like kind of giveaways that you're gonna see is sometimes the constant number is gonna have a constant number of operations. Maybe like just one print, no matter what size the list is. Like print the first one. Okay, you're just printing the first one every time. If the list has one value, doesn't matter, you just do one operation. If the list has 100 values, doesn't matter, you just do one operation. That is like a common pattern that you're gonna see, right? Logarithmic is maybe cutting in half each time. A good example of this could be like a recursive problem. You start with a list that has, I don't know, 100 values. Then for the next recursive call, you only look at half. And then next recursive call, you look at half. So every time you're cutting the value in half. Okay, that is just like one example. Linear, single loop. Let's say I ask you to print the values of every single thing in a list. Like if the list has one value, you're gonna take just one like word. And if it has 100 values, you're gonna print every single one. You're gonna go through element 1, 2, 3, all the way till 100, right? So it is gonna be linear. If you increase the list by 1, the runtime increases by 1. Okay. Quadratic is like, for example, something that you're gonna see very commonly is nested for loops, right? At first, you run through value of the list, and then you want to. A good example, and I don't know if you guys have seen like a legal problem called two-sum or something. You want to see if two values will add to something, right? Let's take that for example. You have the same list, and you want to try the first value of the list plus the second value plus the third value plus the fourth value before you decide to move on to the next value of the list and compare with every single one. So you're trying to see every single combination. In this case, for every run, you run through the entire list again. So you're doing the list to the power of 2. Okay. On exponential, think of tree recursion. You're trying every single combination and it just expands like a tree. Like let's say Fibonacci sequence. Like every single call, you branch out to the n-1 and n-2 values. So you look at the previous two, and those open up and look at the previous two, and those open up and look at the previous two. Just to get your value. You're gonna run through so many different operations. And this is like really bad timing. I mean, ideally everything would be constant, but we're not able to have that in this world. It's just non-existent. Some problems will be forcibly less efficient than others. But it's up to you to make your decisions with code to try to make it as efficient as possible. Okay? And with this is a pretty straightforward problem. But if it's like one of the first times that you go and see this problem, it might seem really confusing. But let's just think about it together. We just want to see what the order of growth is, in depending the size of S. So S is going to be our N, size of N, right? First, the size of S. The code, it's called prefix, right? It first sets variable t equal to 0. We'll have a list, empty list, and then for x in S is going to change the value of t, and then is going to append t. Okay, and then you're gonna return the result of that. Okay, is there any things that you guys want to maybe just recognize or say that you noticed in this pattern you want to shout it out? What are some of the things that you see in this function?
A single loop.
Yeah.
Okay, it's a single loop, okay.
Should be linear.
Linear?
Yeah.
Okay. I see. Linear, yeah. And let's look through it. So first, t does not depend on s, right? You're just assigning a variable. You're creating a variable. Result doesn't depend on s, right? But where it does matter is in this loop here, we're looking through every single value of the list s. So it depends on the size. If s is 1 element long, then you're going to go through it once. If it's 100 elements long, we're going to go through it 100 times, and then we're going to run through everything in the loop, inside of the loop, once every time of the element. And then we're going to return the result. So the single loop is a giveaway. Sometimes it might be tricky, but just always kind of like work and think through the code yourself in your brain. And then you'll like first build intuition, and second you become more handy with this. You'll be able to recognize it just by looking at the function really fast. Okay, any questions on this? Okay. Okay, another example. Still naming is hard. I feel like when I took 61A this summer, this was a problem that really helped me understand a little bit more about how efficiency works. All right. So Pamela created this function to name her child, right? So this function, what it does is returns possible combinations of first and middle name based on names list, where a first name and middle name should not be the same. Any of the name and names can either be first or middle name. So she basically she's gonna pass in a list of names and wants to try every single combination. This is what it works. It will return you a string with the first and middle name for first and name. So for any name in the list, and then any name as a middle name, any name, ensuring that the name is not repeated. Like my name is Luis. I wouldn't try Luis twice. I will skip on that name, but then I will try Luis David, and that's like actually my middle name. Okay. And I try every combination within the thing, and then she's gonna maybe pick one later on. But this is the code that they want you to evaluate.
Okay.
There's another question. Any questions right now? Do you guys want a second to think about it? Yeah, just take your time for a second. I'll put like a maybe a minute timer, and we can gather around and we can all just collaborate on it. Okay. Let's just go through it. Does anybody see anything interesting here? Or anything that you want to point out from just some, you're gonna get more comfortable with this kind of problems that you might be able to just see it right away. Or maybe see like a pattern. So some of the patterns that we showed you earlier, one of them might be present here. So what do you guys think, or when you first saw this problem?
Nested.
There's a nested for loop.
Yeah.
Right? We first look into names to pick the first name, and then we look into names again to pick the last name, just making sure that we're not repeating the same name twice. So it is a nested for loop. So in this case, we're trying the length of the list, right? List of names. You're having the first name, looking through everything but the repeated first name, second, and then the rest, and then just doing the same thing over and over, to the point that the result that we end up getting is going through the length of names to the power of 2. So it will be, in this case, what do you guys think?
Quadratic.
Quadratic. The nested for loop often is a giveaway for quadratic. A lot of these questions in 61A, I would say pretty formulaic. So if you can get like one that represents, like this could be your question for quadratic, like it gives you an example of a nested for loop. Maybe put it on your cheat sheet, remember it, and when you get to the exam, you're gonna see something that's very similar, and then you're gonna be like, oh, shoot, that is quadratic. Okay. Make sure to try one for each one of those times, like at least. Okay. I believe that's everything for efficiency, and then concurrency.
Yeah,
to wrap
so
up.
this is the last topic for this review session, so please bear with me. I know it's been a very long time, so yeah. So this is the last topic. Also, a new topic for this semester. This wasn't in previous semesters. 61A, so you will not see any practice problems on these on the final. So I would recommend looking through discussion and also other CSM problems. Week 11 has a good problem on this. That's my advice. Yeah. So this is completely new, by the way. So yeah, there's a quick disclaimer. All right. So what even is concurrency? So concurrency is basically the ability for a computer system to handle multiple tasks or processes at once. So what this means is that we have more efficient performances on like doing all these tasks. So in Python, if you've seen this in discussion before, we have this async IO library. And what that does is that we use coroutines, which are like objects that kind of like perform tasks. And yeah, so we use the async library in Python and in this class. And this also differs from parallelism because we execute tasks simultaneously on different processors. This is more of a 61C thing. If you're into processors and computer architecture, take 61C for more info on this. But yeah, but in 61A, it just work with the async library for now. And I'll show you the different functions for the Python coroutines. So we have an async def. So what this statement does is that it creates a coroutine function. And what you do is that whenever you call this function, it creates a coroutine. And you kind of can think of a coroutine as kind of like an instance of an object in a class, right? Like an object instance, except that coroutines enable cooperative multitasking, allowing for concurrent execution of tasks, right? So just think of it as kind of like an instance of a new object, but this object can run multiple tasks at once. All good? Any questions on this? All right, cool. So this is a function definition or another function we can use. So like a dot notation, for example. So what this does is that it's used to pause execution and yield control to the event loop until an awaitable object completes. So essentially what you can think of this is that it pauses like the program and waits like a certain amount of time before something is completed, and then it outputs that result. So like after no wait, mutable objects passed into a coroutine may have been changed by another coroutine, right? Because remember, we're running these simultaneously. So it can be a case where like if something that you passed in might have been like altered by another coroutine that also was altering other mutable objects, like a list, for example. Yeah, cool. And we have more function definitions here. So we have async io.run. So C is just like a coroutine. So essentially what it does is just starts some first coroutine that's called C. We also have the sleep function here. What it does is just pauses the coroutine for a k amount of seconds and lets other coroutines run. So what this does is that if you want a specific one to run like C, for example, and you want like another like C2, right? So you want to pause it for like C, you want to pause C and then let C2 run, and then we can let C2 run after that amount of, or like the original C to run after that amount of seconds have elapsed. And then we also have this await of the gather, so it returns. I think it can also run multiple coroutines, not just two. It can run up to n routines. We'll see this in the next example that I've made up. And yeah, so it runs it concurrently until all of the routines that you pass in have returned. So yeah. These functions are pretty good. We'll send the slides afterwards, so you can you don't have to take photos or anything or like rush through the taking your notes. So yeah. But yeah, these are really good to keep in your cheat sheet, especially because this is brand new. So getting familiar with the functionality of all this will be really helpful for the exam. Yeah. Cool. Yeah, so I created this question today. So what we have here is an async function called cook, and what it does is that first it starts the name of what like item we want to cook, and then we do something for something, and then it finishes cooking, and then we just say that it's done cooking. And we can see this function definition being called here. So what we do is that we create a list of tasks, or we pass in each like cooking item and the amount of seconds that we want to delay it by. And then yeah. So given this is like the first time you might have seen this kind of problem, I don't know if you guys want to go through it for like a minute or two, or you guys want to work through it together. Raise of hands if you want to work on it for a bit for yourself. Okay. And then if you want to work through it together. Okay, cool. Then I'll give you guys like 2 minutes, look through it and work through it, and we can come back. And then it just says how long does the program take to run here. There you go. Yeah. In seconds. Yeah.
Then you put the proteins inside. Just define this. First item. It's in the process of there.
Okay.
Oh, second bullet. Is it what a name?
To run tasks.
This wasn't just a lot of people.
No, they have to. You get you remember people to start.
Within the item, you're awaiting like the amount of time.
We know. This other do multiple things stuff.
Don't do multiple things at once, but you can do
Multiple, you'll do like one time, but do multiple.
until the sheds like jobs lease. First and stuff, so the thing and then. And it is so the first already fits like on the sleep.
Yeah.
And then that's the.
That's good. Do you guys want more time, or should we go over this together? Doing good? Yeah. Cool. Yeah, so this so what we do here is that notice that we have this await function, right? And notice that in this function here we have a parameter delay. So what we want to do is essentially have this delay the amount of time that we pass in here. So this parameter here we want to put in delay. Does anyone know or have an idea of what function call that we can call here? that kind of delays this thing by a certain amount of seconds?
Sleep.
Yeah, sleep. So, so what sleep does is that it basically pauses the, let's see if so it basically pauses the coroutine so that it sleeps for this delay amount of seconds here. So, for example, if we pass in pasta, right? It's gonna wait 3 seconds before it starts like running the program. Yeah, cool. All right, we have this other one here, which is results, right? And what we want to essentially do is grab all the items in our task list and run it concurrently together. So, does anyone know what function we can call for this as well?
Gather.
Yeah, right. Gather essentially grabs everything or everything in a stream and eventually or everything like in a collective sequence and it actually runs it all concurrently. The next blank I would say is a little bit kind of very advanced, but essentially this star does, I think, have you seen the star argument in Python before?
Yeah.
Yeah. Yeah, so essentially the star argument just means that it just takes in any like length amount of arguments, right? And what this does on a list is that it unpacks the list and runs it through together. Because the list is so tiny, you can actually probably do it within, you can probably define these as variables and pass the variables in, like separated by commas. Or you can run a for loop and do it on every item of the list, though I think that defeats the purpose of the concurrent running. But yeah. So the best way you could do is that you just define variables here and then call on like the
Gather doesn't take lists, right? It only takes
like the concurrent like
Yeah.
object, yeah.
objects.
So yeah, so that's why you would do the star here on the tasks list. Yeah. But yeah, cool. And does anyone know how long this program takes to run? 4 seconds, right? So just know that for every time you're running anything concurrently, you have to only care about the biggest delay out of all the things that we're running. So that means that this program should take 4 seconds to run. Yay. And that is the end of our review session. So thank you for coming. Really
Thank
appreciate
you.
it. Yeah. Good luck on your finals. You guys got this. You guys got this. Clobber that midterm too. Yeah. Yeah, you guys got it. Yeah.
Wait, dude. It's like, I had talking to the website, sometimes the. We're on our website.